Right now, sunlight is falling on a rooftop somewhere. It hits a flat blue panel. Nothing seems to move. No wires visible. No moving parts at all. But inside that panel, something surprisingly clever is happening. Sunlight is being turned straight into electricity. No fire. No fuel. No spinning turbine like other power plants use. How does light become power? Let's go inside. Crack open a solar panel and you'll find thin wafers of silicon. Silicon is just a common element found in sand and rock, but purified into thin, shiny sheets. Each wafer is split into 2 layers, stacked on top of each other. The top layer has a few atoms swapped in that give it extra electrons, tiny negatively charged particles. The bottom layer has atoms swapped in that leave it short a few electrons instead. Think of the top layer as a bucket with too much water. Think of the bottom layer as a bucket with a few gaps, waiting to be filled. Where these 2 layers touch, something interesting happens automatically. Extra electrons from the top drift down to fill the gaps below. This creates an invisible electric field right at the boundary, like a wall standing between the 2 layers. Now sunlight arrives. Sunlight is made of tiny packets of energy called photons. When a photon slams into the silicon, it knocks an electron loose, the same way a cue ball knocks a billiard ball out of place. That loose electron gets caught by the invisible wall at the boundary. The wall pushes it in one direction only, like a one-way turnstile at a train station. 1 photon. 1 freed electron. 1 push in the same direction every single time. Multiply that by trillions of photons hitting the panel every second, and you get a steady stream of electrons all moving the same way. That steady stream is electric current. But there's a catch. Electrons need somewhere to go, or they just pile up. That's why thin metal strips run across the top of every solar cell, visible as those faint silver lines you can see on a panel. The strips catch the moving electrons and guide them out of the cell, through a wire, and into your home's electrical system. The electrons flow through your lights, your fridge, your phone charger, doing work along the way. Then they loop back into the bottom of the panel to start the journey again. Here's the one clever idea that makes the whole thing work. The panel doesn't burn anything, spin anything, or heat any water to make steam. It uses the built-in electric field between 2 layers of silicon as a permanent one-way door for electrons, and sunlight is simply the key that keeps knocking electrons loose so they can walk through that door. But a single cell only makes a tiny trickle of power, barely enough to run a calculator. So panels wire hundreds of these cells together in a grid, adding their tiny trickles into one strong current. There's one more twist. The electricity coming out of the panel flows in only one direction, called direct current. But most homes run on electricity that switches direction rapidly, called alternating current. So before that power reaches your outlets, a device called an inverter, basically a translator for electricity, converts it into the form your house actually uses. Zoom out, and the scale becomes staggering. A single rooftop can hold enough cells to power an entire home. Vast fields of panels, stretching for miles across deserts, now feed electricity into entire cities, all from the same simple mechanism happening inside every single cell. No moving parts. No fuel burned. Just sunlight, silicon, and an invisible wall built to catch electrons and send them where you need them. So next time you walk past a rooftop with a flat blue panel catching the sun, remember what's really happening up there. Somewhere inside that quiet, motionless surface, countless tiny electrons are being knocked loose and pushed through an invisible one-way door, turning ordinary sunlight into the power running through your entire home.